Hello friends. So the topic I am going to cover in this video is the introduction to complex number. So first I am starting with an basic equation x square minus 1 equals to 0 and another equation x square plus 1 equals to 0. So if I solve the first equation, that is x minus 1 into x plus 1 equals to 0, which will imply x minus 1 equals to 0 or x plus 1 0, so which will give x equals to 1 or minus 1. So 1 and minus 1 are the roots of the first equation. Now fundamental theorem of algebra says that every equation with positive power of x and the real coefficient has at least one root. So that means this equation also has at least one root. Now x square equals to minus 1. So if I send the plus 1 to the right hand side, I will get x square equals to minus 1. So that means the value of the x should be x equals to plus minus root under minus 1. But in the real number system, we all know that the square root of positive number is valid. But here we are getting square root of negative number. But fundamental theorem of algebra also says that every equation with positive power of x and real coefficient has at least one root. So that means this should be the root of this equation. But in the real number system, this thing this thing is not valid in real number system. Okay. Again, if I choose another equation, suppose x square plus 4 equals to 0, so that will imply x equals to plus minus root under of minus 4. So I can write root under of minus 4 as plus minus root under minus 1 into root 4, which will give plus minus 2 root under minus 1. So as we can see, in every this type of equation, this root under minus 1 is the common term. As we can see, the root under minus 1 is common for all those numbers where the term under the square root is negative. Then we denote this root under minus 1 by I, where I has the special name iota, and I represents the imaginary unit. Why it is imaginary? Because in case of real number system, we know that the under the square root every number is positive in real number system, but here the term under the square root is coming as negative. That's why this imaginary term is coming. Okay, before I talk about the powers of I should tell about the rule for the product when the two numbers are under square root, like root a root b. I am taking the product of these two numbers when a and b are greater than 0. So you know this is easily root under ab. Now a greater than 0, b less than 0. So this will give root a into root b. This is again root under a into b, where ab is less than 0 and here ab is greater than 0. But when a less than 0, b less than 0, so root under a into root under b is not equals to root ab. Okay, and I will keep this rule in our mind, and then I will perform the powers of I. So let's try to find the powers of I. First, I square. I square is I into I that means root under minus 1 into root under minus 1. And as I told before, that if a b both are negative, then root under a into root under b is not equals to root ab. So that means root under minus 1 into root under minus 1 is not equals to root under minus 1 into minus 1, that is root under 1 equals to 1. So how to calculate this product? So let's see. This is equals to root under minus 1 to the power 2, that is minus 1 to the power half whole to the power 2. Now I can cancel this 2 and 2, so I am getting minus 1. So finally I am getting the value of I square as minus 1. Okay. So next I am trying to find the value of I cube. So actually I should include I cube, I to the power 5, those things also in this series. Okay, so let's try to find the value of I to the power 3 or I cube. So I cube equals to I into I square. We can write it as this. That is, we all know from the previous one that I square is minus 1. So I am getting minus 1 into I. So that is minus I. I to the power 4. That is I square into I square. We all know I square is minus 1. And this is again minus 1. So it is coming as 1. So we are getting I cube equals to minus I. And I to the power 4 equals to 1. Again, we can find the value of I to the power 5, I to the power 6 and more higher powers of I. So let's try to find I to the power 5 first. I to the power 5 equals to I to the power 4 into I. So that means I to the power 4 is 1. So 1 into I, which is I. I to the power 6. This is I to the power 4 into I square. This is 1 and this is minus 1, that is coming as minus 1. So as we can see from this calculation that any power of I can be written as the nearest multiple of 4 plus some constant number. That is, in case of 5, this is 4 into 1 plus 1. In case of 6, 4 into 1 plus 2. So nearest multiple of 4 plus some constant number. Now let's try to find the more higher power of I. That is, suppose we are trying to find the power of I where the power is suppose 49. So 49 can be written as 48 plus 1 because this is the nearest power of 4, nearest multiple of 4. So write it as 48 into I. Now 48 is I to the power 4 whole to the power 12 into I. Now I to the power 4 is 1. So 1 to the power 12 into I, that is I. Similarly, let's try to find more higher degree, that is I to the power 99. So what is the value? I to the power 99, nearest multiple of 4 is 96 plus 3. So 96 I to the power 96 into I cube. 96, this I to the power 4 whole to the power 24 into I cube. This is 1, so 1 to the power 24 and I cube is minus I. So this is minus I. So the value is minus I. Therefore, I to the power 99 is minus I. So in this way, we can easily find the more and more higher degree of the I.